Cape Town?
Yeah.
Great. Okay, what's your question?
Okay, it's cosθ
Mm-hmm.
plus square root 3
Yep.
sinθ
Mm-hmm.
equal to 2, and it's solve for theta general solution.
General solution. Okay. You're a higher grader?
Yeah.
Okay. Did you know where to start at all? Or was this just a total
yeah,
brick
I
wall?
divided by 2 first.
Okay, why did you do that?
I don't know, it seemed like the first thing to do.
Seems like the intelligent thing to do.
Yeah.
Okay, just very quickly, if we'd have had an equation that had just had cos on the left and a single term, let's say sine on the right,
Yeah.
do you agree you would have divided by cos and that would have been a straight tan equation?
Yeah.
Okay. Notice that our thetas are both simple angles. They're not compound, so there's nothing that we can do to break them up and use double angles or anything like that. Okay. We've got 3 terms, but 3 terms normally is a trinomial, and so again we stuck. It's not a trinomial. So your idea to actually divide by 2 is really great, okay? But what I'm going to suggest is instead of writing it as divide by 2, I'm going to times by a half. Okay, so let's go back to that, and I'm going to say let's times by a half. And so this is going to become a half cos theta.
Yeah.
Plus root 3 over 2 sin theta, and timesing the right-hand side is 1. Okay, now what?
Okay, now a half and root 3 over 2 are special angles.
Yes, they are. They actually, as a result of special angles, so let's just put in a special angle triangle over here. I know that we have calculators now that can do special angles for us, but of course it's really good to be able to think through it yourself. So our special angle 60, 30. Okay, can you tell me the dimensions of this triangle?
Okay, it's 1, 2, root 3.
Where must I put the 1?
1 on adjacent.
Mm-hmm.
2 on the hypotenuse.
Yes.
And root 3 on the opposite.
Shot. Okay. All right, so looking at what you've got a half. Now go to your actual special angle triangle, and what is a half equivalent to? What ratio is it?
Sin 30.
Okay, it is sine of 30.
Or cos 60, so sin 30.
Absolutely. You could have gone either way. Either it's the sine of 30 or it's the cos of 60. And of course those are co-ratios, so of course either way you would have been doing something completely correct. Okay, from exactly the same picture, what do you know about root 3 over 2 as a ratio?
Okay, that gives you either sin 60 or cos 30.
Okay, which one do you want me to use?
Cos 30.
Cos 30. Okay, so let's make it cos 30 times the sine of theta equal to 1. Okay, you're absolutely perfect so far. Now what?
That's double angle.
Okay, you say it's a double angle. All right, are you sure it's a double angle or is it a compound angle?
Okay, yeah.
Okay, there's a difference, isn't it? Okay, all right. So it's going sine cos, cos sine. So which compound angle expansion is it?
It would be the sine one.
Okay, because remember that if you have sine of A plus B, what does that expand to?
Sine 30 degrees plus theta.
Okay, well, no, just take a backward step for me, Nick. So if I've just got sine of A plus B, what does that expand to?
Sine A cos B.
Yes.
Plus cos A sin B.
All right, and that's exactly what you've got here, isn't it?
Yeah.
Except A is in the place of the 30 and B is working in the same place as the theta. Okay, well, it sounds like you know what you're doing. So this is the same as the sine of, what did you say?
30 degrees, it would be, yeah, plus theta, 30 degrees plus theta.
Okay, is equal to 1.
Yeah.
Okay, now you're actually there because we can now go for our reference angle by second functioning sine. So pick up your calculator and what are you going to get?
Okay, 60 degrees.
60, okay. So the sine...
No, wait, it's 90, sorry.
90,
yeah.
Okay, alrighty, let's just delete our little mistake there and let's go back. So you're saying now that your reference angle is going to be that theta plus 30 is 90 degrees.
Yeah.
Okay, now remember it's general solution, Nick, so what should we add?
Plus 360 degrees K.
Okay.
Or in 360 degree or whatever.
All right, and so K is an element of Z.
Yeah.
Okay. All right, now we're going to solve our equation now into our two respective quadrants. So could you continue for me?
Okay, therefore theta equals 60 degrees.
Okay, just so that the learners out there can also follow you, do you now go into the two quadrants, or do you work with 180 minus in that second quadrant? How do you go from here to get your two solutions?
Because it's general solution, you just take it into, take the 30 across, and then it'll give you 90 degrees minus 30.
Okay, all right. So your first quadrant solution is you're going to take your theta across. All right, I'm happy with what you're saying. So you're going to get theta is 60, yes, plus K360.
Yeah.
All right. Or what else?
Okay, now, but also on the K360, you got to minus the 30 as well. So it would be K330.
No, you don't. Okay, that's a wonderful thing that you've just said there, because we often find students making that mistake. The K360 is your period. So the only time that you actually fiddle with that K360 is if you had some kind of a number in front of the theta.
Okay.
So if it was a 2 theta or a 3 theta or a half theta, then that affects your period. Okay. Otherwise, you just subtract it from your actual angle. Okay, so I'm glad that you made that quick slip, because that was a good chance for me to clarify that. Okay, now, but we're not finished yet, because there's still another part of this general solution.
Second quadrant.
Tell me, how are we going to get that one?
Okay, it's in the 180 degrees minus theta quadrant. So it would give you, let me just do this. Okay, it would give you 180 degrees minus 60.
Yes.
It would give you 120 degrees. So theta would equal 120 degrees plus 360 degrees K.
Okay, so you're saying 180 minus 30 plus theta is equal to 180 minus 90 plus K360. And so you said finally theta was equal to? Say that again for me.
Theta equals 120 degrees plus 360 degrees K.
120.
Yeah.
Okay, let's just go back and check that.
90. Wait, no,
okay.
120.
Remember that our reference angle was 90. So in our second quadrant, we would say 180 minus our reference, which would give us 90. Wouldn't it?
Yeah.
180 minus 90 is 90. And then we're still bringing the 30 to subtract it.
Let's look at the 60, yeah.
So is it 120 or is it 60?
It's 60.
It's 60. Okay.
Yeah, oops.
Okay. All right. Oops. There we go. All right. You happy that you've done the question?
Yeah, cool.
Great. Thank you very much. Good luck.
Thanks a lot.